Jai Hind everyone. I am Achintya Pandey, as a assistant professor in IT department at Ajay Kumar Garg Engineering College. Today I will discuss about virtual function, or you can say in-depth runtime polymorphism. How this runtime polymorphism could be achieved using the concept of virtual function that we will see. Okay. Before virtual functions, let me see what is polymorphism. As you know, polymorphism or even the word means is one word having different meaning depending on the context. So the concept of polymorphism basically is implemented using function overloading or a virtual function. Actually, the polymorphism can be categorized into two categories. One is compile time polymorphism, and second one is runtime polymorphism, right? So, so compile time polymorphism is achieved by using the concept of you can say function overloading or operator overloading, right? Compile time polymorphism. Sometimes it is called static polymorphism, or you can say early time polymorphism. And second, that is runtime polymorphism. That could be achieved by using the concept of virtual function, or even this runtime polymorphism is sometimes called late binding, or you can say it as a dynamic binding. So let's have a bird eye view on this concept. Then we will discuss specifically the virtual function, how we can create the pointer to an object, basically base object, that could be used to store the address of base object as well as derived object, and by that using the concept of function overriding, we could achieve the runtime polymorphism. Okay, so like says, there are two types of polymorphism in C++. One is compile time polymorphism. It is called a static or early binding, and this could be achieved by using the concept of function and operator overloading, right? And second category is runtime polymorphism. So, as the name suggests, something runtime means at the time of running, but this is not automatically, achieved. To achieve runtime polymorphism, we will see that we would have to write some code, we would have to write virtual functions and all that. Then and only runtime polymorphism could be achieved. Okay, so this is called sometimes dynamic, or even this is wrong. This is not early. This is late binding. Okay, this is wrongly written. So runtime polymorphism is sometimes called dynamic or late binding, and using the concept of virtual function, you could achieve this runtime polymorphism. Okay, so so how we could implement this virtual function in C++, that we'll see. So there will be need of the concept of pointer to derived classes, or you can say pointer to object. How by using pointer to derived classes, also you can say pointer to object, we can achieve the function overriding. Okay. Okay, suppose we have a base class like class base, and this is the definition of base class. I mean, data and function will be there, and say the name of derived class is class derived, means derived class is going to inherit base class. So this is the simple declaration in using C++. What we name the name of derived class, say here derived, and this is the public base, means this one is going to inherit this base class. So colon public base and all. Okay. Okay, now we have created a base class pointer which will be pointing to the address of base class object, like here P1. So we can simply create base asterisk P1, and we have simply we have a object d obg, d underscore obg means this is the object of derived class, and similarly we can create the b obg means object of base class. Okay, so what here we are trying to do? So in P1 is what? P1 is pointer to base class. So this pointer to base class, in the pointer to base class, we can assign the address of derived class also. Okay. So there are two ways. Either you can write like this, or even by using the keyword new, you could give the address of derived class. Okay. There are two ways to assign the address of object. One is by using the pointer, and other one is by using the keyword new. So by using even the new keyword, we can give the address of object derived class into this P2 pointer. So P2 or P1 both are, you can say, and there are two different ways to assign the address of derived class. Okay, or even the base class. Okay, so we can see that by using the pointer to base class, we can assign the address of derived class, but vice versa is not true. We cannot make a pointer to this derived class and assign the address of base class, base object into this pointer. There is no way that you create the pointer to derive, like you can create derive stick say P3, okay, and you cannot assign P3 equal to address of say B underscore obj. Okay, so let me remind, in base class pointer you can assign the address of derived class, but vice versa is not possible. If you want to assign that, then you need to typecast and all that. Okay, so this is all. Using a base class pointer, we can access only those members of the derived object that were inherited from the base. So it is different from the behavior that Java. So we can get Java-like behavior using virtual function. This is because the base pointer has knowledge only of the base class. It knows nothing about the member added by the derived class. Okay. For example, let me explore with some kind of C++ programming. So here is a base class that is base class base, and in this, for example, we have used a function. There is no private data or any data is not here. Say for example, we have, just for the sake of complexity, we have simply using a function so, and in so we have just written a simple code, print say base. Okay, so this is the base class, this is the derived class which is going to inherit this base class. Okay, and of course this is public inheritance, means the public member of this could be inherited using in this derived class. Okay, so here also we have used the same same function so, and simply a line of code, just printing derived, right? Now we have created a base class object b1.show. Of course it will print base. So here we derive, then we have used a derive object d1.show. What will we invoke? This derive by using dot operator. By use we have already discussed that in my last video that any member function or data, public data, could be accessed by the object of that class by simply using the operator dot. So d1 is object of the derived class. So d1 dot show means this function will be invoked. Simple. Now, the main is we have now created an object to the base class object, right? Like PB. So PB is pointer to the base class object. Okay. So this is a pointer to the class base. So we can assign the address of B1. Suppose B1 is what? Object of the base class. So we can assign address of base class object into this PB. And another way to print to invoke member function of any class is by using the pointer. As we already know that there are two ways to access the member function. One is by using the dot operator, and simply by using the name of object followed by dot, and you can give the member function name that would be invoked. Or another way is by creating the pointer to the object. Okay, so we can make a pointer of the class, and by using the pointer we would have to write this operator arrow. So there are two ways, either by using the dot, right, like b1 dot show dot object followed by dot and member function, or pointer to the object and followed by this arrow operator and name of the member function. So two way to invoke member function, either by dot operator or by the arrow operator. If you are using arrow operator, then you need to create the pointer. Anyway, so this is a simple way to access this member function or data. Okay, so pointer to derived class. So this is, you can say, this is pointer to base class, and if similarly we could make pointer to derived class. Even we can create derived asterisk say PD, and you can assign the address of derived, and you can do like that. But pointer to base class has the capability to store the address of its subsequent subclass or derived class. So even by using this pointer to base class, this means this PB could store the address of base object, that is okay. But this base class pointer could store even the address of derived class, like here. So PB equal to address of D1. So this pointer to base class is capable to store the address of base class object as well as the derived class object. Now, if you, so for example, PB and arrow operator, so which function will be invoked either in the base class or of the derived class. So once you invoke using the pointer to base class, then it will invoke the derived class object. Okay. See, this is called function overriding. Function overloading, the concept, see the difference in function overloading and function overriding is that in function overloading, or we can say early binding or static binding, depending on the match, compiler match, if there is a difference in say number of argument, type of argument, so depending on exact match, that particular function will be invoked. But if all match, say in a function, for example, here show return type is void, here also return type is void, there is no parameter, so exact it is same. So which function could invoked? So this is the case of function overriding, and this could be achieved at runtime. So we see that if you want to invoke the derived class function, if you want to invoke the derived class function, then we need to give the address of derived class object using the base class pointer. Okay. So if you write this, this will not invoke this function which is in the base class, it will invoke the function which is inside the derived class. That is important to know. Okay. So that's why it is written in something bold color. So this will pb dot show this will show base. Okay. Sorry. Actually, if you want this derived class function to get invoked, okay, so there is a need to, the concept of virtual function. Until and unless if you not define virtual function, then only base class function will be invoked. Again, let me clear. If, see, once again, we have declared a base class pointer which is having the address of base class object. Now, this base class pointer, I mean pointer to base class, okay, is capable to store the address of course, base class object, as well as you can store the address of derived class object. But if you want to invoke this show function which is having the same signature, I mean return type, number of argument, type of argument, everything is same, then which function would invoke? Either in the class of base class or it is in the derived class. Okay. So normally it will invoke only the base class function. That is thing. Now, so here we have seen that what will be output will come? Only this function will be invoked. In normal way, only this function will be invoked. But if you want that this derived class function should be invoked, then this is only possible then if you write or if you make one function, if you make it this function as a virtual function. If you make this function as a virtual function, then and only the new subclass function will be invoked. So you would need to write here virtual void show, okay, then and only. So this is what, this is not early binding, this is not late binding, and this is not dynamic binding, this is what early binding or static binding. Okay, so this will always show the base class. Okay. Now, so this is already say pointer to derived class. So let's see, this we have already discussed, how you can make the pointer to base class, pointer to any class, how you can make, just like you make the integer type pointer or float pointer or any primitive pointer, you can make the pointer to any class. So you can make the pointer to base class, we can make the pointer to the derived class. Like here, you can say that we could make derived PD is derived class pointer. Okay, even you can assign the address. Okay, so PD is what? PD could not store, of course, the PB, I mean base class pointer. Okay, but if you want to do, then you need to typecast. So this is another thing. Now, similarly, pointer to derived class, like pointer to any class, you can make the pointer to derived class simply by using the asterisk command. Okay, so pointer to derived class. Pointer arithmetic means if you add something like +1 +2, so +1 +2 next location. So one thing important, pointer arithmetic is relative to the data type the pointer is declared is a pointing to. If you point a base pointer to a derived object and then increment the pointer, it will not pointing to the next derived class, but it will be pointing to the next base class object. Okay. Okay, so you could be careful about this. Okay, so this is some important point of inheritance. In C++, only public inheritance support the perfect is a relationship, because in the public inheritance you can inherit public and protected data base class. In case of private and protected inheritance, we cannot treat a derived class object in the same way as base class object, because if you privately inherit, then public and all, public protected, all data of base class become the private, and you cannot directly accessed by the object of that derived class object. So these are some important point. Public member of the base class become private are protected in the derived class and hence cannot be accessed directly by others using the derived class object. If we use private or protected inheritance, we cannot assign the address of a derived class object to a base class pointer directly. We need to typecast. Okay. So this is some important point of inheritance you should know. But this is one of the reasons for which Java only support public inheritance. Okay. Maybe this would be reason and Java only support public inheritance because ultimately in public inheritance you can inherit the public or protected base class. So if you say base class you are going to inherit privately, then the public and protected or even private data is never accessible by derived class object. But if you inherit privately a base class, then even the even the public and protected data of base class become the private and you cannot access by the object of that derived class. So these all are some points. Now, so introduction to virtual function. Let me again remind this what we here. Here we have used show function in base class. Here we have also used show function in derived class. The signature of function is same in both base and derived class. Signature means the return type as well as the number of argument type of everything is same. Then which function should invoke? Okay. So we have seen that only base class function is going to invoke in normal cases. Okay. But if you want to inherit the new or sub function, a sub class, I mean derived class, which you create later as the software developer. Okay. So if you want to invoke that function, then how you could invoke? So for that, we use the concept of virtual function. Okay. So let's see what is virtual function. So a virtual function is also is a member function. Okay. That is declared within a base class and redefined. That is called overriding by a derived class. It implements the one interface multiple method philosophy and that underlies polymorphism. And to make virtual function, we are required to use the keyword virtual keyword. Okay, to designate a member function as a virtual function. This support runtime polymorphism. Okay, or it is called late binding with the help of base class pointer. So a base class pointer, we require the base class pointer because in the base class pointer, you can store the address of base class object as well as the derived class object. Okay. So while redefining a virtual function in a derived class, the function signature must match the original function present in the base class. So we call it overriding, not overloading. Okay. So when a virtual function is redefined by a derived class, the keyword virtual is not needed. When redefined, virtual keyword could be only used in the base class. You can also use even the virtual keyword in derived class, but it is not, it is optional. Either you want, you can write. But by just making virtual keyword only in the base class, it means that function you are going to make it virtual. Okay. So let's see the implementation here. The same program, I mean a function say so, which is in the base class as well as in the derived class. Now, what is the difference is we make this so function as a virtual function and we will see what the difference is by using the concept of, or you can say by creating the pointer to the base class object. Okay. So same function, just we make or use virtual keyword. So virtual word so, and the same thing. So we have B1 is the object of base class. B1 dot so, what function will invoke? This base class, simple. So this is S dot V means static binding, compiled type polymorphism. Similarly, we have created the derived class object D1, D1 dot so simply will of course invoke the function so in derived class. So this is derived static binding. Now we have created a base class pointer PB in which we have assigned the address of base class object, it is B1, and this PB could store the address of this derived class object. Okay. Now, so if you invoke PB so, because in PB we have assigned the address of base class object, so if you invoke the so function like this, it will of course display this base. Now we are making this PB to store the address of, I mean this is pointing to now derived class object. So if you make the base class pointer to point the derived class, so we need to assign the address of derived class object into this base class pointer. Now this is pointing to derived class, and then if you invoke this so function, then it will not invoke this base class function. It will invoke the derived class. Why it is because we have made this so function as a virtual function, so this will not invoke, and only the derived class object will be invoked. So here we have seen that in this particular two-line code, so the function in derived class gets invoked, and that is invoked at runtime. So we have written some code to achieve this runtime polymorphism. Okay. So this is the difference. Okay. So if you want something, the code, you want it to be invoked at runtime, or you want the same function signature should invoke in a derived class object, then we would have to make the function as a virtual function. Okay. The same function name you are using in the base class as well as derived class, and the signature of the function is same, and you want the function, you want the derived class function gets invoked, then we must make the function as a virtual function. Okay. So this is what we want to explore. This is simple for showing some, a little more about, virtual function. So we have seen that virtual function is what? This is also a member function, and you make this member function as a by using the keyword of virtual as a virtual function. So this virtual function itself, it is virtual function and pure virtual function. So what is pure virtual function? If you want to omit the body of a virtual function in a base class, like we have seen, we have written something, a line of code. If you want to omit, you do not want to write anything, just as an abstract class, you can make abstract class. Okay, so you can if you want to omit the body of a function, there is no this is called pure virtual functions, and pure virtual function means you can write like this. Nothing you are going to write in base class. It is just as a reference. So this itself make this base class as an abstract class. The such class is called abstract class. We are just using for abstractions. Okay. So we cannot create any object of such classes. We cannot create object of this abstract classes. Okay. It forces a derived class to override it. Okay. So by making virtual function, we override, okay, the base function, and we execute the derived class on it. Okay. So what is pure virtual function? So this pure virtual function means you can omit the function body in the base class, right? And this you can do by like this, equal to 0. Okay. So this is all about, you can say that virtual function or pure virtual function. So this is what we have extracted. So let's see So final comment is runtime polymorphism is not automatically activated in C++, like it is automatically activated in Java, but in C++ we need to make that function as a virtual function, then and only by the help of pointer to base class we can invoke that. Okay, so we have to use virtual function and base class pointer to enforce and activate runtime polymorphism in C++. It is not automatically activated, but in Java runtime polymorphism is automatically present, as all non-static method of a class are by default virtual in nature. We just need to use superclass reference to point to subclass object to achieve runtime polymorphism. That is the difference between Java and C++. Java has eliminated, and it is automatically invoked. Okay, so that's what these are some key points what discuss. Okay, so once again, let me summarize what is virtual function or runtime polymorphism. So we have what we have seen in this today's class. So we have seen that polymorphism could be of compile time, runtime polymorphism, compile time polymorphism, sometimes called early or compile time binding. Okay, and runtime polymorphism. If we use the concept of virtual function, then we could achieve the runtime polymorphism, and with the help of base class pointer, this we could. So this is all about this. We have used Balaguru Swami and all in this video. Okay, so that's all about. So thank you. Good day and Jai Hind.